Hello, myself is Anil Kumar Sharma. I am from Sham Academy. Today I am here to give a lecture on the topic motion. So, as you already know how to define a motion. In simple terms, if we are moving a hand, this is a motion. If we are moving our body, this is a motion. But when we see more that motion, then we see if something is moving, we are saying it is in motion. But for motion, we have to consider some reference. If something, if an object is moving with some stationary point, then we say it is in motion. As you have seen in road by, you are standing and you have considered some reference point like pole or etc. Then considering that reference point, you will see that every object is moving. So simple motion we can define: if any object is moving with some fixed reference, then we said the object is said to be in motion. So here I can write what is motion. If an object is changing its position with respect to some reference point or fixed point, then the object is said to be in motion. So if an object is changing its position with respect to some reference point or fixed point, then the object is said to be in motion. Now next comes, we have studied how to define a motion. Next come, what are the different terms that are related with motion. Now first comes distance, because if a motion is there, distance should be covered or distance should be there. Then second, the term is displacement. Now here we have to study both the terms, what is distance and what is displacement. Now the distance is simply, we can say, the distance traveled by an object irrespective of the direction. If an object is moving, like I consider a motion in a straight path, here I am considering a motion of object in straight path. So this will become clear. Now here this A is, I am taking as a reference point or origin, and this A, B, C, like D, and this is the end point A. Now if I say this distance is say 10 kilometer, this is again 10 kilometer, and this I say it is little less 8 kilometer, and this again I say it's 8 kilometer. Now how to define distance? If a person is starting from the point A and he is traveling in this straight direction, when he will reach at point B, he will cover a distance of 10 kilometer. If he further reaches at point C, the distance covered is now 10 plus 10, 20 kilometer. At A it was 10 kilometer, now at B it is 20 kilometer. Again further at D, how much it will become? It is becoming 28 kilometer, and here it final become 36 kilometer. So in case of distance, it is we are simply adding the distance, how much it is traveling from a fixed reference. Now what happens, he start moving back towards the C points. So again, how much the distance will be traveled? 36 plus 8, here it is 44 kilometer, and again at C it is 52 kilometer. So distance is simply how much journey is taken by an object in kilometer, irrespective of its motion. Now let us come to the other quantity, that is displacement. Now how we will differentiate both distance and displacement? Now in case of displacement, we can say it is the shortest distance from initial point to final point. Means whatever the distance you are traveling, the displacement will be considered by the initial point and final point, and also the shortest distance. So here in this case, we have traveled from A to E, then E to C. The distance traveled is 52 kilometer. We have just keep on adding the distances, but what will be the displacement? Here you will see in displacement we will consider this initial position A, and what is the final position? Final position is C, to A to C. It is the shortest distance. What is the shortest distance? 10 and 10, it's 20 kilometer. So here what is displacement? In displacement, the distance traveled is only 20 kilometer, but the actual distance, if you will see how much distance traveled, it is 52 kilometer. So what we are considering in displacement? We are considering initial position, final point, and it is the shortest distance. So here you can see in distance, we irrespective of the direction we keep on adding the distances, and in case of displacement we first consider the initial point, then consider final point, and then we see the shortest distance. So distance, it is a scalar quantity. Now I will write how we differentiate distance and displacement. Distance, it is a scalar quantity and it is a vector quantity. Now what is the meaning of scalar quantity? Distance means here we are considering magnitude only. When we are measuring the distance, we are considering magnitude only, but in case of displacement, here we are considering magnitude with direction. How the direction? Because here we are saying that displacement is from the shortest distance. Shortest distance, here we are considering shortest distance from initial to final. So here it is coming magnitude with direction. What is the third? Distance can never be 0. Distance traveled can never be 0, but displacement can be 0. How displacement can be 0? Suppose I am considering from a path from A to B. Say it is 10 kilometer. Now again I am coming from B to A. Now when I go from A to B, it is 10 kilometer. Again from B to A, it is 10 kilometer. So how much the distance traveled? It is 20 kilometer. But what is the displacement? Displacement initially point is A and final point again it is A. So what is the displacement? It can be 0. Here displacement is 0. So this is the three major difference which we can find in distance and displacement. Now the next term is how to define a speed. Now the next comes how to define speed. Now the speed, it is given by a simple formula, distance upon time. Speed, we can define the distance traveled by an object in a given time. This is the distance traveled by an object in a given time. It is represented by the speed. How we can say, suppose here the speed of an object is 10 kilometer per hour. So what is the meaning of this? It means the distance traveled is 10 kilometer in 1 hour. So speed, we can simply define distance upon time. Then next terms comes, what is uniform speed? What is the meaning of uniform speed? Uniform speed, or I can say constant speed. Now as I mentioned here, the speed is 10 kilometer per hour. Means in 1 hour the distance traveled is 10 kilometer. Here I am considering time and here I am considering distance. So in 1 hour the distance traveled is 10 kilometer. Now if I say 2 hours, so what will be the distance? It will be 20 kilometer. In 3 hours the distance will be 30 kilometer. In 4 hours it will be 40 kilometer. So what you are getting here? Here you are getting a uniform speed. So uniform speed, how we can define? We can define it is the distance traveled equal in equal intervals of time. Equal distance traveled in equal intervals of time. As you see from this example, there is a equal time is there, 1 hour, and the distance again is 10 10 10 10 10 10. So it is the uniform speed. In uniform speed the distance traveled is equal in equal intervals of time. And if we draw the graph of a uniform speed, you can see this will come like a straight line. Here I will show the graph of, here I am considering say time and here I am considering distance. So if I mark like this and here I am marking this, if roughly expression, this will come like this, a straight line. It means if it is 1 hour it is 10, if it is 2 hour it is 20, if it is 3 hour it is 30, and 4 hour it is 40. So if I will see like this, this will come like this and this little bit. So the graph of a uniform motion, or constant motion, graph between time and distance. So this will always be like a straight line, because here the distance traveled is in proportional to time. But if I see, if it is a non-uniform motion, In a non-uniform motion, the graph can be like this, or maybe different. It can be like this. So here what is changing? Here in non-uniform motion, you will see that the distance traveled, it is not equal in equal interval of time. Here I can write, say, time and distance. So here it can be, suppose initially it was moving 10 kilometer 1 hour. Say 1 hour it takes 10 kilometer. Now in say in 2 hours, instead of 20 it becomes 30 kilometer, or in 3 hours now again it becomes say 45 kilometer, and in 4 hours it becomes 60 kilometers. So here the time interval is 1, but the distance is here initially it is 20, it is 15, it is 15, it is not the same. So such type of motions in which equal distances are not covered in equal intervals of time, these are known as non-uniform motions. And in uniform motions you will see always like a straight line curve, because here the distance traveled is equal in equal interval of time. Now here we define the speed. Now the same way if we approach towards the velocity. Now what is the difference between speed and velocity? Now as we see the difference between distance and displacement, in the same way we can define the difference between speed and velocity, because here velocity is, we say, it comes with the direction. Velocity, it is a vector quantity. It is with direction is also involved in a velocity, but in case of speed, what we see only the magnitude. As in case of your distance, we consider only the distance traveled, and in displacement it was the distance with direction. So that comes in the velocity, vector quantity. So let us see what is the difference between speed and velocity. Here I am speed and velocity. Now how we define the speed? It is the distance traveled per unit time. So here I can write speed is distance traveled divided by the time taken. Now but when we define velocity, it is the distance traveled in a given direction divided by the time taken. So in case of velocity, we are defining distance traveled with the direction. Here we are not considering the direction. Second, speed, it is a scalar quantity, and velocity, it is a vector quantity. So what is the meaning of scalar? Here we are considering only magnitude, and in case of magnitude with direction. So in case of speed we use distance, and in velocity we can also write displacement divided by time taken. So this is the simple difference how we can differentiate speed and velocity. Next here come what is average speed and average velocity. Now what is the meaning of average? Average speed, when we consider, when sometimes the motion is uniform motion, sometimes it is non-uniform motion, means sometimes the speed of an object is high and sometimes it is less. So here we have to find the average speed. So in case of average speed, what we consider? We consider the total distance traveled. Total distance traveled divided by total time taken. Now, what is average velocity? Simply average velocity we can define by the sum of initial velocity plus final velocity divided by 2. So, in average speed we just consider total distance traveled divided by the total time taken, or in average velocity we consider initial velocity plus final velocity divided by 2, or we can also consider by this the displacement divided by the total time taken. So, in case of average velocity we have to consider the direction also. So, here we have written displacement with the total time taken, but in case of average speed we have just mentioned it is the total distance traveled with total time taken. Now, next is comes over how to define your acceleration. Now, next is acceleration. Now, as we see the velocity, so acceleration it is defined by the rate of change of velocity. How? Here we can say if an object is moving with say initial velocity say u and its final velocity is v. So, though acceleration it is rate of change of velocity. So, what is rate of change of velocity? Final velocity v minus initial velocity divided by t. So, it is a. So, acceleration can be simply defined by the change in velocity with time. So, what is its SI unit? What becomes? What is the unit of velocity? Velocity it is always in meter per second, or you can also use kilometer per hour. So, acceleration, what acceleration becomes? Meter per second square. So, acceleration is the rate of change of velocity. Now, similarly, as we have studied uniform speed, we can also have uniform acceleration, and the second is non-uniform acceleration. Now, how we can define uniform acceleration? In uniform acceleration, this rate of change of velocity is equal in equal intervals of time. So, here I can mention it is the rate of change of velocity is equal in equal intervals of time. But in case of non-uniform acceleration, rate of change of velocity is not equal in equal intervals of time. So, this is the difference, because uniform means you can say constant acceleration and non-uniform means when the rate of change of velocity is changing in the given interval of time. This we can also see by the graph. Okay. Next we see the graph of the velocity time graphs. Graphs for velocity time. First we consider uniform, in case of uniform motion. Now here what will be the graph like? The graph will be like this. If I am considering here I am considering the time, and here I am considering velocity. This point is our initial point. Here we can consider say position 1, 2, 3, 4 hour. Now what I am drawing here, it is 1, 2, 3, 4. Now this is our velocity, say it is in kilometer per hour, and what it is starting from 1. Now if I consider this velocity say 10 kilometer per hour. Now here in velocity time graph, what I am consider here I am consider a uniform motion, or I can say uniform velocity. So this speed velocity is say fixed 10 kilometer. Now what does this graph then can show? Now this graph can show me or give me the distance traveled or displacement, because in case of velocity we consider displacement, but I am mentioning here distance, so that is same, because in velocity we see the displacement, but I am writing here distance, so don't get confused with that. Here we have to find how to find the displacement from the graph. So here you will see the velocity is constant, so I have shown a straight line, and this is time 1, 2, 3. So suppose at this point I have to find the distance traveled. So how you can find? This is the time and this is the, so this you can just find the by the area of rectangle. Suppose I have to point this, say I O A, B and C. Now the area of O A B C, what is this? This is OA, this 10 OA into OC, this OA. So what is OA? It is 10 into C is 30, sorry 3. So what it will become? 30 kilometer. So by the velocity time graph, here you are seeing it is very easy to find the distance traveled. At any point you can measure. Suppose I have to find it here, so the time will be 4, this 10 will remain same. So this graph is used for finding the distance traveled or displacement. Let us see one more graph in the case of uniform acceleration. Here I am drawing the graph velocity time graph for uniform acceleration. Now here this is our time, and what I am showing here is, here this is velocity time graph for uniform acceleration. What is it mean? Uniform acceleration means the velocity changing with time. So here this is your velocity and time. Time I can take in hours or velocity in meter or kilometer per hour. So as we have seen in uniform motion, in constant uniform motion, the graph with distance with times comes to be a straight line. So again here it is the same, the velocity, change in velocity with respect to time, it is coming same. So but what the point is, what here we can find? Here we can find, say now what is the use of this graph? Here you can see, suppose I have to find the distance traveled or displacement from their point to this point. So how we can find? We can find just by finding the area. So in this graph, the distance traveled it is given by the area of rectangle A C D E plus area of triangle A B E. So the area gives the distance or displacement either in case of velocity time graph with uniform acceleration or velocity time graph in case of uniform motion. Means here we can use the graph to calculate the distance traveled. The same concept we use in case of to derive the equation of motion. So next over comes equations of motion. Now in equation of motion there are three equations of motions which we generally derive. V equal to u plus at, second is s equal to ut plus half at square, and the third is 2as equal to v square minus u square. Now before deriving this equation, first we have to consider the motion type. It is a uniform, an object is moving with an uniform motion, or we can say it is with uniform acceleration. The initial velocity of an object is initial velocity is u meter per second. Final velocity is equal to v meter per second, and the time taken is t second. Distance traveled is equal to s. So if an object is moving with a initial velocity u with final velocity v and the time taken is t, so the distance traveled is s. All these relations we get by the graph. Okay, now I have write here the equation of motion. V equal to u plus at, s equal to ut plus half at square, v square minus u square equal to 2as. Here we have considered a motion of an object in a straight line with uniform acceleration having initial velocity u meter per second, final velocity v meter per second, time taken t, and the distance traveled is s. Now here we will derive these equations by considering a simple graph. Say I am drawing here a first graph like this. Here it is, we are considering time, and here we are considering velocity. So we are considering here u initial velocity, say, and the object is moving with at this point, say, final velocity, and then we are drawing perpendicular to like this. So what I can write here, O, A, this point say B, C, D. Now here this is velocity in meter per second, here it is time second. So now this point u is initial velocity, and this point B is object is moving with final velocity. So here from this graph I can write here, if an object is moving with an initial velocity, OA equal to u equal to initial velocity, and he reaches at final velocity at point B is v. So what I can write here, it is BD, the final velocity, OA is initial velocity, and BD equal to V equal to final velocity, and the time taken is OD. OD equal to T equal to time taken. Now what I have to derive equation? I have to derive the equation. The first one is equal to V equal to U plus AT. So what is this? This is velocity time relation. Now to derive this equation, I have mentioned here the initial velocity, final velocity, time taken, and of course acceleration is A. The object acceleration is uniform acceleration equal to A. Now how we can approach this? As we know that how to define acceleration. Acceleration is nothing but it is the rate of change of velocity, or what I can write, velocity, final velocity minus initial velocity divided by time taken. Now if I see from the graph, the change in velocity is nothing but it is BC. BC is what? It is BD minus CD. BC divided by what is time taken? Time taken is OD. So what is this BC? This BC is nothing but BD minus CD. Here I can write BD minus CD divided by OD. Now what is BD? BD I have mentioned V. What is CD? CD is nothing but OA. Here I can also write CD is OA. So what I can write, BD, BD means V minus CD is U divided by T. This is nothing but A. So V minus U cross multiplying AT, and V equal to U plus AT. So this is the first equation which we have derived from this graph. This is very simple. This is your U and this is your V. And what is this? This is V minus U. So this is the first equation of motion, a simple ratio relation, V equal to U plus AT. In the second, what is that? The second equation is S equal to UT plus half AT square. Now what is this? This is our position time relation. Now how to derive this position time relation? Position means S, distance traveled, and time is T. So as I have seen you in previous graphs that with this graph we can also measure the distance. So here the distance traveled is nothing but distance traveled is equal to the area covered by trapezium. What is trapezium? Is OABD, by the trapezium OABDO. OABDO. This is some sort of trapezium. So here we can also divide into two parts. This area we can write, this area is the sum of area of OA. I have mentioned here C. OAC. This OACD plus area of ABC. This area of triangle, and this is area of rectangle. This is OACD plus area of this triangle ABC is nothing but that area of trapezium. So what is area of rectangle? This is OA multiplied by OD plus area of triangle. What is half into base? Base is nothing but AC into this height. What is height? BC. So here I can write what is OA. OA is nothing but U, and what is OD? OD is nothing but T plus half. What is AC? AC is nothing but again AC is equal to OD. This is AC is equal to OD. So what is this? Time. And what is BC? BC is nothing but it is V minus U. So now you will see here the relation distance which I am representing by S is become U into T plus half into T into V minus U. Now as we derive from the previous relationship V minus U equal to AT. Now this I can substitute here. So this equation become S equal to UT plus half T into AT. So this is nothing but S equal to UT plus half A T square. This is T, this is cross AT. So this is the second relation. This is known as position time relation, which we have derived from this in a simple manner. Now the third and the last relation is your position and velocity. Position velocity relation, that is given by V square minus U square equal to 2AS. Now how we will derive from the same graph? Here we will consider again the area of trapezium OABDO. It is given by there is a direct formula of trapezium, half into sum of parallel sides into height. This is the direct formula which we can apply here. So area is nothing but as it is half into sum of parallel sides. If you will see from the previous diagram or previous graph, the sum of parallel side is nothing but it is U plus V into what is this? Height. So height, what will become? Height will become T. So this you will mention T. So now what you have to do here? Here we have to put this value of T. Now from this equation, from the first equation, V minus U equal to AT or T equal to V minus U upon A. Here I am going to substitute this as equal to half U plus V into T is V minus U upon A. I can rearrange this like this as equal to U V plus U. I can write first V then U, V minus U divided by 2A. This implies 2A as equal to V plus U into V minus U. Now here you can use A plus B, A minus B. It is nothing but V square minus U square equal to 2AS. So this is the equation, third one, which we have derived from a simple graph, and this is known as position velocity, in the relation between position velocity. So these are the three equations of motion. Now there is one last topic remains in this motion, that is known as uniform circular motion. Now we will see what is that uniform circular motion. Now as you already know that a circular motion, what is happening in a circular motion, or what is a circular motion? You will see if an object is moving in a circle, like if you are rotating some thread or you have tied some stone and you are rotating like this and you are creating a circular motion, then such type of motions are known as circular motions, in which you can also consider planets revolving around the earth, or like other examples in which a circular motion can be defined. So in circular motion, what we have to study, we have to see that there is a change in velocity, or the motion is a uniform accelerated one, or what type of motion. So as we know that how we can change a motion. Here we are considering uniform motion. So in uniform motion, it means magnitude is constant. But if magnitude is constant, then how the motion, it can be an accelerated one. So in case of accelerated motion, there should be change in velocity. So how the velocity can be changed? As we know that velocity, it depends on magnitude with direction. Magnitude with direction. So here what is happening? Here the magnitude is constant, but the direction is changing. At each and every point, direction gets changed. So direction, due to the change in direction, there is a change in velocity. Because if you see from step by step, then you can draw it is like a rectangle, then the curve will like a pentagon, hexagon, octagon, in the same way, then the finally it will come in a circular point. So here, even though the magnitude is constant, but still the velocity is changing. Why the velocity is changing? Because velocity depends on magnitude with direction. So here direction is changing. How the direction is changing? Sometimes you have seen when you are rotating a stone like this, and whenever you release, at that point where you will release, it will go in the straight direction. So this shows that this is the direction is changing at each point. So the uniform circular motion, even the magnitude is constant, but the velocity is changing. So this motion is said to be an accelerated one. So here in this, again we can find the velocity. So this was all about the motion, in which we have studied from starting the basic to the uniform circular motion. Thanks a lot, and for further query you can contact me at Study Khazana. Thank you.